algebra students, Mr. Lawrence here with your next flipped lesson, and we're going to be solving literal equations. Now, some of you are going to look at this and go, I don't get it, but actually it's super duper simple. Look, if you know how to solve an equation like this, then solving these is going to be just as easy. The only trick is we're not going to be solving problems that necessarily have lots of numbers in them. They're going to have lots of letters. You just have to know which letter you're solving for. And problem number one, I'm going to ask you to solve for r. Okay, it says d equals rt. You should recognize that. If you don't, you certainly will by the end of your 8th grade year. It's a very famous formula. Distance equals the rate times the time. And, you know, for example, if you are driving at 60 miles an hour for 3 hours, well, what distance have you gone? Well, of course, 180 miles an hour. Or, excuse me, 180 miles. 60 miles per hour times 1 hour, 3 hours, ends up being 180 miles. Okay, so we're going to solve for r in this problem. I'm going to circle r, it's my variable, and I'm going to treat the t and the d as variables, or excuse me, as constants. They're not variables in this case. So, what's our goal? To get the r alone. What number is keeping the r alone from being alone? The t. How is it attached? Well, multiplication. How do you undo that? Well, I'm going to divide. What number should I divide by? Yt, of course. I have to do it to both sides. So the rate is going to equal the distance divided by the time. And there you go. So in other words, if you know how far you went and how long it took you to get there, you can figure out how fast you were going. That's what that tells you. Problem number 2 should look familiar from last year. C equals pi d. The circumference of a circle can be found by multiplying pi times the diameter of the circle. Now, I don't know if you realize this, but pi is not 3.414. Pi does not equal 3.14. No, this is an irrational number, okay? And this is a rational number. They're not the same thing. Sometimes we use this to represent pi, but they're not the same thing at all. In fact, if I do this, hold on one second, let me pause the video, and I just Googled the first 100,000 digits of pi, you can see that it starts off, hold on, this is in your way, 3.1415, right? But then it just keeps going. That's all part of pi. Now, pi is an irrational number because it goes forever, and you can see I haven't scrolled down very far, and I've already passed a ton of digits. It just keeps going, 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 and there's no pattern to the repetition. Like, for example, you see right here, I have some ones repeating, right? But then there's no pattern to it. It goes 111, 25996028. There's a 1, but it doesn't start over with 3 ones. It goes 1839, and it just, there is no pattern to it. The digits repeat, of course, because you only have 10 digits you can use from 0 to 9, but it just keeps going forever and ever and ever. And where did my mouse go? I lost my mouse. Mouse, there it is. Okay, if I just keep going, look at that. Okay, now you're not even looking at 1% of pi, because pi goes forever and ever. It's not even a half a percent. It's not a tenth of a percent. It just goes and goes and goes. All right, so pi is not the same as 3.14. That's just an estimation of it. All right, so in this problem, I'm going to ask you to solve for pi. Okay, so the problem's going to have to tell you what to solve for. In this case, we're going to solve for pi. Okay, well, what's my goal? To get pi alone. What number is keeping pi from being alone? The d. How is it attached? Multiplication. How will I do that? Well, I'll divide each side by d. And so I'll get pi can be found by taking the circumference and dividing it by the diameter of a circle. Okay, this is pretty easy stuff. You just have to realize that the other letters act just like numbers. They're just unknown numbers is all they are. Okay, on this one here, I'm going to have you solve for h. Solve for h. Hopefully you recognize this formula. It's the formula for the area of a trapezoid. You know, one pair of parallel sides. Okay, sometimes they look like that. Sometimes they look like this. And if you take the average of the two bases, add the two bases together, divide by 2, that's the average of the bases, multiply by the height of the trapezoid, you will get the area of the trapezoid. Well, we're going to solve for h. Now, I know you know how to get rid of fractions, and so that's going to be the way I solve this one. I'm going to get rid of the fractions by multiplying both sides by 2 over 1, or just plain old 2. And then I'm going to do it a different way because I'm going to show you something really simple. Okay, the left-hand side is going to be 2a. Right-hand side, the 2 over 2 will cancel, leaving me with the quantity of b sub 1 plus b sub 2 times h. What's keeping the h from being alone? Well, the sum of the two bases. So I'm going to divide by b sub 1 plus b sub 2. And I have to do it on the other side as well. And then the right-hand side, these will cancel. And h will be equal to 2 times the area divided by the sum of the bases. Okay? Now there's another way to think about this problem, and I'm going to back up here to show you how I might think about it. Actually, maybe I'll just do it over here. I'll rewrite the formula a. We're going to let that equal b sub 1 plus b sub 2 divided by 2 times h. Now, I know that I'm going to multiply by 2 and then divide by b sub 1 plus b sub 2. Well, isn't that like using the reciprocal, multiplying by 2, and then dividing by b sub 1 plus b sub 2? That's like using the reciprocal. So I'm going to put a over 1, and I'll multiply a over 1 by this, b sub 1 plus b sub 2. And then over here on the right, the 2 over 2 will cancel. The b sub 1 plus b sub 2 will cancel with that b sub 1 plus b sub 2, leaving me just with h. The left-hand side, nothing will cancel. My numerator will become 2a. My denominator will be the sum of the two bases. And you see I get the same exact answer. It's not really one less step. It's more like two steps are combined in one. Okay, one last sample problem. In this problem, we're going to solve for y. This will actually turn our equation into a very special form of a linear equation that we're going to be using a lot of later on. Right now it's in what we call standard form, but we're going to convert it to something called slope-intercept form. It just means solve for y right now. So I'm going to circle the y. And I ask myself, what's my goal? Well, to get the y alone. What numbers are keeping the y from being alone? Well, the 3, of course, but the other number is actually the 2x. Yeah, that's the other number keeping y from being alone. How is the 2x attached? Well, it's a positive 2x, so it's by addition. The 3 is next to the y, the negative 3 is next to y, so it is multiplication. So, to get y alone, Saddam is going to tell me to get rid of the addition first. So I'm going to subtract 2x from both sides. The left-hand side is going to become negative 3y. Now the right-hand side, some of you are going to have trouble with, but pay attention. Are they like terms? Are 6 and 2x like terms? No, of course they're not. They can't be put together. They're not like terms. So I'm just going to write it down. Now you have two choices. You could write down 6 minus 2x, and that would be perfectly acceptable. I'm going to suggest to you that you write down minus 2x plus 6. It's the same thing as 6 minus 2x, but down the road, this way will help keep you from making a mistake. Okay, I'm not going to go into the mistake right now. I'm just going to suggest to write the x term first. You will not lose points if you don't write the x term first, but I'm telling you it'll be easier later. Okay, y is still not alone. I have a negative 3 attached to it by multiplication, so I'll divide by negative 3. And you have to be careful here. Make sure you divide both terms by negative 3. Okay, so the left-hand side, the negative 3y, or negative 3 is canceled, leaving me y. 6 over negative 3 is negative 2, of course. Now this one here is going to mess some of you up. The fraction itself won't simplify, but I have a negative divided by a negative. And so those negatives cancel out, and I end up with a 2/3 x. And there you go. Y is all by itself. And I'm actually ready to graph. We're not graphing right now, but this is a great way to graph. This is easy to graph. Okay, so there's the 4 examples. It shouldn't be that difficult for you. I'm going to sign off. We'll see you tomorrow. Good night, everybody. Now,